In this lecture, we will look into the fundamentals of the data analysis when applied on the data set and the statistical analysis is performed as ungrouped. So this is a very simple example to understand the idea. Suppose we have collected a data set and the values of the data set are taken as values of x that are 118, 123, 124, 125, 127 and onwards till we get the last value which is 154. So this is the data set that we have got. The question is this, that find the following statistical parameters for the given data set using both ungrouped and grouped methods of data summarization. We have to find the range, quartiles, some percentile value which is 15th percentile in this case, some decile value which is 8th decile in this case, the middle value of the data, frequency distribution of x, the mean value of x, errors in the mean value, and the predicted outcome. So let's first start with the range. And remember, we are at this moment only doing the analysis as ungrouped data statistics. Later on, we will do the group data statistics. so, so let's first start with the range. Remember, my dear students, I would ask you that always remember this thing that if if you come across with a new word in your technical subjects, then it is much better that first find the dictionary meaning of it. If we know the dictionary meanings of the technical jargons that we come across in these subjects, then sometimes understanding the concept becomes very easier. Like for example, we have the case over here. We have to find the range of the data set. Now what a range is? Basically, range means the distance. So this means that when we are finding the range in the data set, we means to find the distance in the data set. And normally, when we talk about the distance, so the distance means this, that the distance from the lowest value to the highest value, or the distance from the minimum value to the maximum value. In order to find this distance or the range, we have to follow the two steps procedure. And the first step is this, to basically first arrange the data in the ascending order. By ascending order, what we mean? By ascending order, we mean that the lowest value should come first, then the next higher value, then the next higher value, and the last value should be the highest among all. So at first, we have to arrange the data in the ascending order. Definitely, as can be understood, when we do this thing, then the lowest value would be the first value, as I just said, and the highest value would be the last value. Now the second step is this, find the distance. And in mathematics, the basic method to find the distance is finding the difference between the maximum value and the minimum value, or finding the difference between the two values always gives us the range between them or the distance between them. So in order to calculate the distance in the data set or the range in the data set, we have to find the difference between the maximum value of x and the minimum value of x. If we indicate the maximum value of x with x max and the minimum value of x with x min, then the difference between the two, that is x max minus x min, which is 154 minus 118, that is 36, is the range in the data set. Now this is the mathematical answer, and we should be very proud of it that, oh, we have got something in the analysis. But always remember that in statistics, getting the mathematical answer is one thing, and what does that answer mean? That is the interpretation that I talked about in my previous lecture. The interpretation of this answer is more important. So what do we mean by the statistics? Actually, the magnitude of this result tells us the the extent to which the variations or the randomization in the data set is present. Now, to understand this idea, let's let's say that in my data set that we were discussing over here, suppose the maximum value was not 154, rather it was 254. Now, if it was 254, then the range would have been the difference between 254 and 118. And then the result of this subtraction would have been 136 rather than 36. So definitely 136 is a value which is much greater than, it is much greater than the previous range that we determined, and that was 36. So what does it mean? 136 means that the dispersion or the randomization or the variations in the values are much higher as compared to the one that we solved previously, which gave us the range which was 36. So range basically tells us the extent of dispersion present in the dataset. By distance in the dataset, we mean that how much the values are different from each other. The more the values are different from each other, the more would be the dispersion present, the more would be the randomization present, and the more would be the range, or the more would be the distance. So this is the idea of the range. So let's resume the things to their actual values so that it does not disturb our further analysis. So I hope this idea of range is now understandable to everybody. It's a simple idea, simple concept, but very important in statistics. Now next comes the quartiles. Actually, whether we talk about the quartiles or we talk about the deciles or we talk about the percentiles, they basically mean, conceptually, they basically mean the same thing. And what do they mean? They mean the purpose of finding, of using these quartiles, percentiles, and deciles is this, that they mean to find the positions, different positions in the data set. Now, in order to understand the core idea, the fundamental idea of the positioning in the data set, let's take a very simple example, which I many times put in my class. Now, you can see this is a small piece of plastic. Suppose this is a data set, or just take it as a small piece of plastic. If I ask you that in order to divide this plastic in two portions, that is, if I want to have two portions of this small piece of plastic, then how many cuts would be required? How many cuts I need to divide this piece of plastic in two pieces? What is the answer? Yes, one. I need one cut to divide this piece of plastic in two pieces. I can place this one cut over here, anywhere. And if I say that I want to divide this plastic in two equal pieces, then again one cut would be required and it will be placed in the middle position. If I ask you that I want to divide this piece of plastic in three pieces, I want three portions in it, and let's say equal three portions, then definitely I need two cuts, and there would be specified positions of them because I want equal three pieces. If I want to divide this piece of plastic in four equal pieces, then I need three cuts, and the positions of those three cuts would be definitely specific because I want equal portions. So this is the basic idea. It's very simple to understand and very interesting as well. So the idea is this, that the number of cuts required to divide certain thing is equal to 1 minus the total portions that we want. So if I want four portions, I will be needing three cuts, and they would have specific positions. If I want, let's say, five portions, then I can have those five portions using the four cuts, and they would have their positions of it. So this is the basic idea of what quartiles, percentiles, and deciles do. When we talk about the quartiles, so quartile is a word taken from quarters, and quarter means four. So by quartiles, we mean dividing the data in 4 parts, right? So remember that quartile is from quarters, or let's let's make it much more easier to understand, to remember rather. So I would be writing it in a different slide. So quartiles is from quarters, sorry, and by quarter we mean 4. So when we want to find the quartiles, then it means we are dividing the data set in 4 parts. And we would see just now that how we do this thing. But just as an introduction, I'm writing it over here. And when we talk about the percentiles, percentiles is a word taken from percent, or rather percentage. And by percentage or percent, we mean 100. So when we talk about the percentiles, then it will always mean to divide the data in 100 equal parts. And when we talk about the deciles, then decile is a word taken from deci, and deci means 10. So I'm just writing some keywords over here so that you will always remember by their name that what are we trying to find. So when we talk about the deciles, it means dividing the data in 10 equal parts. That's why these are called the deciles. And the theory, the concept that we just discussed, when we want 4 parts, then this could be done by 3 positioning cuts. Let me just correct the spelling of it. And when we talk about the percentiles, in order to get 100 parts, 100 equal parts, then this could be done by 99 positioning cuts. And when we talk about the deciles, this could be done by 9 positioning cuts, right? So 4 parts, 4 parts can be obtained by 3 positioning cuts. And these 3 positioning cuts are basically called the quartiles. So we name them as Q1, and then Q2, and then Q3. So Q is for quartile, and 1 means that the first position, which will give us the first portion. Q2 or quartile 2 means the second position, which will cumulatively from with the first one will give us 2 positions. And then Q3 is the quartile 3, which will give us 2 more positions. And in this way, we'll get the 4 portions, right? Likewise, we have the percentiles. Just as we discussed, they are used to give the 100 divisions. And in order to get the 100 divisions, this could be done by 99 percentiles. I'll be short over here because we have earlier wrote all these things as in the quartiles. So this could be done by 99 percentiles, and they are indicated by P with subscript or notation like P1, P2, till we can have the most value, which is P 99. And likewise, for the deciles which divide the data in 10 equal parts, this could be done by 9 deciles, and they are indicated by D1 for decile 1, D2 for decile 2, and onwards we can have the last value, which is D9, right? So this is the basic idea. Now let's see in detail that what do we mean by it and how this is done. So for the given data set, which was basically this one, it was required to find the quartiles in it. So this is the data set, and we want to find the quartiles in this data set. That is the positions. By virtue of them, we can divide this data into four portions. So again, this is a simple procedure, not a very complicated one. There are three steps to follow. The first one is this: to basically arrange the data in the ascending order. This is the first step, right? And this we have already done, because not we have done it, but luckily our data, if you look into the data set that is present over here, is already in the ascending order, just like we discussed in the range calculations. So the smallest value is the first one and the highest value is the last one, and in between they are all in the ascending order. So the first step is already done for us. But remember that do arrange it in an ascending order if it is not so. Otherwise, you will get incorrect answers. Then the second step to perform is find the location of the quartiles. This is important one, because we need to locate the position where we want the quartile to be present. We need to have that specific position, right? So for example, if I ask you that what would be this specific positions, so definitely when we talk about the quartiles and they are dividing the data in four parts, then the first position would be at 25th percent point in the data set. The second one, or the quartile 2, would be at the 50th percent point in the data set, which is the middle position, remember. And the third quartile Q3 would be at the 75th percent point on the data set. So they are at 1 upon 4, 2 upon 4, and 3 upon 4 uh, points on the given data set. And once the location has been determined, the last step is to find the value that is present on that location. It is just a simple example that if for example, if I want to locate somebody, if I want to meet somebody, then first I need to have the map of it, the map of the area. Then I need to have the address of the person, the location, and then only I can, once I have the map, I have the address, then only I can basically go over there and basically meet him. So this is the idea of the quartiles, percentiles, and deciles as well. In order to find the location of the quartile, we have a very simple formula, and this formula is Qi is equal to I upon 4 and whole multiplied by n plus 1. Now, what is I in this formula? I is the index number which can have value 1, 2, or 3. If I is 1, then it means quartile 1. If I is 2, then it means quartile 2. And if I is 3, then it means quartile 3. Capital N is the total data set size. In our case, it is 17. So I upon 4 means 1 upon 4, that means 0.25, 25th percent position. When I is 2, it is 2 upon 4, which is 1 upon 2, that is 0.5 or 50th percent position. And when I is 3, then it will be, this portion would be 3 by 4, that means 0.75 percent position of n plus 1. Usually students ask this thing that why we are adding plus 1 with n. You can also do this calculation with only n over here, but I mean statistically it has been determined, like empirically it has been determined as well, that plus 1 basically reduces the errors in the result. So that's why we have put plus 1 over here. But when the data size is huge, it's very large, we don't take the plus 1 in this equation. And we would see this when we would be discussing the group data statistics. So let's come to the conclusion, to the calculation, sorry. The location first. In all these locations, I have indicated it with the at the rate sign so that we may not be confused that location is a different thing and the value of the Q1 is the second thing. So at the rate is just to indicate that it is the address or the location. So at the rate Q1 means finding the location of Q1, and using this formula, I is 1, so 1 upon 4 into 17 plus 1. And when we do this calculation on our calculators, we get a value which is 4.5. But instead of writing it just 4.5, since it is the location, so we write it as 4.5th location. So that means that starting from the left hand side, that is from the minimum value in the data set, at 4.5th location is located my Q1 or quartile 1 value, right? And what is that value? Now, let's see how we find this value. This value can be determined very easily, and this is the data set, and we just saw this thing that at 4.5th position is the Q1. So 4.5 means that this is the first value, first position. The value 118 is at the first position. The value 123 is at the second position. The value 124 is at the third position. And the value 125 is at the fourth position. So that means at fourth position we have 125, but since our location was 4.5, so this means we have to move zero point 0.5 ahead from 125, and this will be the quartile 1 value. So zero point 0.5 of what? 0.5 of the distance between the thing that is located at the fourth position and the thing that is located at the fifth position. So we have to reach to zero point 0.5 of this distance. Okay, and how we do this thing? The distance between the fourth and fifth, as we just saw that the distance is the difference of the two values. So at fourth it is written 125, and at fifth it is written 127. So the distance between the two is 127 minus 125, and 0.5 of it can be found by multiplying this distance with 0.5. So this will give us the 58% of this distance, and whatever the answer comes out, we add it to the one that is present at the fourth position. So this is the fourth position, and on at fourth position we had the value which was 125, and then we add it with zero point 0.5 of the distance from the fourth to fifth, and the calculation of this simple equation gives us the value which is 126. So we first have to find the difference between the two. It gives the answer 2. 2 when multiplied with zero point 0.5 is 1, and 1 plus 125 is 126. So that means 126 is the quartile 1 value, right? So in our data set, for example, 126 would be somewhere in between 125 and 127. So this basically means that our quartile 1 value is basically somewhere in between 125 and 126. So this is the quartile 1 position, right? And just in the same way, we find the quartile 2. So first step is already done for us, that is arranging the data in the ascending order. Second step, the location, and the location is determined by this equation that I upon 4 into n plus 1, that is I in this case is 2. So 2 upon 4 multiplied by 17 plus 1, so 18 into 2 upon 4, and the answer is 9. But since it is just the location, so we write it as ninth location. And this basically means that whatever is written on the ninth location in our data set is the quartile 2 value. And remember that quartile 2 value is the value which divides the data in two equal parts, right? So it's basically the 50th point in the data set. So that means at ninth location, if we count from here, so we have at first position we have 118, then 123. So this is second, then third, fourth, fifth, sixth, seventh, eighth, and ninth. So that means this is the ninth location, and on the ninth location, we just make a marker over here so we may remember what we are doing. On the ninth location, we have the value which is 131. So that means this is the quartile 2 position, and this is what the quartile 2 value is. And as we can see, this is the middle point in the data set as well. It is dividing the data in two equal parts, right? We have basically 1, 2, 3, 4, 5, 6, 7, 8 values on its right hand side, and 1, 2, 3, 4, 5, 6, 7, 8 values on its left hand side. So this is the 50th% location in the data set as well. And since it is the middle value, therefore we also call it as the quartile 2 value is also called as the middle value or the median of the data set, right? And in the same way, we find the quartile 3 value as well. And this is 3 upon 4 into 17 plus 1. I is 3 in this case, capital N is 17. And this gives us 13.5, which is read as 13.5th location. And this basically means that we have to reach from the left hand side till 13th position, and on 13th we have 141, and then you have to find the difference between what is written from 13th to 14th position and the point 0.5 of this distance added with the one that is on the 13th position, which is 141, will give us the 141.5 value, which is the quartile 3 value. So that's how we calculate this quartile 3 value. Now, why we use the quartiles? The first thing, as we have already discussed, it tells us the positions in the data set. It gives us different points in the data set at some specific positions. But there's also a very important reason of finding the quartiles. And this the answer to this question is basically the interquartile range, or the distance between the quartiles. When we talk about the interquartile range, then since again it's the distance, so it's the distance between the minimum value of quartile and the maximum value of quartile. The maximum value of quartile is Q3, which is 141.5, and the minimum value of quartile is Q1, which is 126, and the difference between the two is 15.5. So this is the IQR, or the interquartile range. And why we find it, why we use it. In order to understand this idea, let's take a simple scenario. But before doing the simple scenario, let's first put our Q3 value, which was somewhere over here, I guess between 141 and 142. This was for the Q3 position and value, which was 141.5. So suppose during the collection of the data set, let's say that something happens that, I mean, abruptly we get a very high value, and then again the normal values that we are getting, or suddenly we get something very low in value as compared to the others. Like for example, it happens that sometimes during while working at home or in offices, it happens that sometimes the current intensity of the current exceeds randomly up to a very high value, and then it again becomes normal, or it becomes very low and again it becomes normal. So if that could happen, then this would mean that we are getting something very high as very few values, and if we have arranged the data in the ascending order, then this would be somewhere at the end. So suppose I get a very high value which is different from the others, and this is like 354, suppose. Now if this would have been the case, and if I find a range in the data set, then this range would be 354 minus 118, for example, and the answer would be what? It would be basically 236. So let's see, it's 236, 14 minus 8 is 6, and 4 minus, so 14 is 3, 4 minus 1 is 3, and then we have 3 minus 1, which is 2. So 236 is a very big range. But as a data analyst, suppose if I look into my data, I see, or I have some idea about my data set, and see that this is not possible. I have some idea of my data set, and I say that I cannot get such a huge range. There should be some problem. There's some error. Suppose I have got this doubt in my data, in my analysis. So there should be a way to verify this thing. There should be a way to justify my doubt, to clarify my doubt. And then what we do is this: we trim the data. We trim the data equally from both sides. We can trim the data at 5% positions, 10% positions, or whatsoever, and then find a new range. If the new range is higher as and similar as this previous one, then we would say that yes, this data has a big randomization present. A standard way to doing of trimming is this: that we cut the data at 25% positions. So I mean, we would cut the data, we would cut this part of the data, and we would cut this part of the data. And please see this thing: when we are doing it, it means we are only considering the values which are present between Q1 and Q3, quartile 1 and quartile 3, and the distance between the two, that is between quartile 1 and quartile 3, is what we call the interquartile range. And suppose if this is the data set, and if I get the interquartile range to be 15.5, then definitely it should alarm me that if IQR is 15.5 and the range is 236, then definitely something wrong has happened. Some error has occurred because the rest of the data does not agree with the range of 236. So after doing this, our responsibility as a data analyst is this: to either to look for the errors, recollect the data, and try to rectify the data if the error is really present. So that's all for the quartiles. And the next lecture we will be discussing about the percentiles and the deciles. Thank you.